Hello, in this last of our climate change podcasts, we're going to be looking at solutions for slowing climate change. And our learning targets for this podcast is that we will understand how individuals can slow climate change, and we'll also understand how laws, policies, and treaties can slow climate change. First, there are challenges. One is that the problem is global. It requires international cooperation. Now, the effects are long-term, so that the CO2 emitted today will be around for 120 years. And if we pass a tipping point, the effects could be around for thousands of years. And this challenge we covered in an earlier podcast. The long-term political issues are very hard to solve because most of those who feel the effects of climate change have yet to be born. We see today how hard it is to solve short-term issues. Long-term issues are even harder. And when there's climate change, there will both be winners and there will be losers. There are nations where they'll actually benefit from climate change. And there are, of course, nations where they will lose out. Like if sea level rises enough, there are nations that will disappear. There are island nations that will be completely underwater. But we won't really know who the winners will be and exactly who the losers will be until it is too late. Also, many solutions will disrupt economies and lifestyles, but waiting too long will be more disruptive. I'll give you a sports analogy for making changes. Let's say in hockey you want to block a puck from going into a goal. If you're far away from the goal, then you don't have to move the puck all that much in order to make it miss the goal. But if more time has gone by and the puck is closer to the goal, then you have to make a much greater change to the puck in order for it to miss the goal. So the sooner that we make the changes, the less we have to do in order to avoid disaster. There are four main strategies that are involved in combating climate change. One of these is to improve energy efficiency to reduce fossil fuel use. The second is to shift from using non-renewable fossil fuels to renewable carbon-free energy sources. Examples of carbon-free energy sources would be things like using wind power, using solar power, using hydroelectric power, even using nuclear power. A third would be to stop cutting down tropical rainforests. Two reasons why tropical rainforests are involved with this. One is that they're able to soak up the CO2 that are in the atmosphere. Also, burning the trees themselves release the carbon dioxide into the atmosphere. The fourth is to sequester CO2 into vegetation, underground, and the deep ocean, and hope that they never leak out. And all of these would be enhanced by reducing the human population, because if there are fewer people in the world than is projected, less energy is going to be used than is projected, which means that we wouldn't have to reduce fossil fuel as much as projected in order to combat climate change. Next couple slides, we're going to see how you can be a part of the solution. One is drive less. You can use public transportation, you can carpool, bike, walk, buy a used car with good mileage. Good mileage is over 30 miles per gallon. How does this help? Imagine a bus full of people or a subway full of people that's using profoundly less gasoline than having all of those people using cars. Not as good a solution, but still a good solution is to carpool. As many people as are carpooling, that takes that many cars off the road. Biking, walking, in addition to exercising and saving money by not having to buy more gas, that will also cut down on burning fossil fuels. Now this last one here, buying a used car with good mileage, two good things about this. First, buying a used car. When you buy a new car, that car has actually already traveled the majority of the distance that it's going to travel when you buy it. Because first thing is that it was assembled in another country, then it's already traveled across the ocean to get to you. Second thing is that the parts for a car come from all over the world. The parts of the car have already traveled more than you will ever drive that car before you ever bought that car new. And when you buy a used car, then that's already been done. Now with the good mileage, there are several advantages to good mileage. One is that it saves you money because you don't have to fill up the car as much. And the second is that it's not burning as many fossil fuels. Making your house efficient. One definite advantage of that is it's going to save you money. You can insulate and seal all drafts. A good way to judge the insulation of your house is look at the roof of your house after it snows. Compare how long it takes for the snow on your roof to melt compared to other houses. If it takes a fairly long time, that means you've got good insulation. If it takes a short time, that means you've got bad insulation and the heat is leaking from your house, melting the snow. Planting a tree so your house is shaded will also save energy, because when you've got less sunlight shining on your house, that means that you won't have to use as much air conditioning to cool it in the summer. In a very warm climate, if you paint it light, that will reflect sunlight. And if you're in a very cold climate, then painting it dark will help also. For appliances, you should use Energy Star appliances because those will save energy. Then wash laundry in warm or cold water. Don't use hot because hot uses energy. And also, look over here, this one here, see, it says cold water. This washes at lower temperatures just as well as other detergents do at higher temperatures. So that can save you energy and also can help save the climate with that. If you use a high efficiency washing machine, you have to make sure that they get detergent that says HE on there, or else it's going to ruin your washing machine, because the way those work, you have to use low suds on that. Also produce less waste. You can buy minimally packaged goods, recycle and reuse. Like when you go to the supermarket, bring your own canvas bags. Don't use the bags that they have there. And there are some supermarkets where actually give you a slight discount if you bring your own bags. Also, some utilities allow you to buy renewable energy. It brings up the cost of your bill a little bit. Other possibilities that you could do is it's possible for you to actually turn your home into a mini power plant sometimes. It's also possible, particularly for people who are living in New York City or in Westchester, say for Con Ed, that if you have central heat or central air, that you have a thermostat, and you can get in touch with Con Ed, and they will put in a programmable thermostats in your home, and you can program those with your smartphone or any computer just on the internet when you're away from home. You change the settings of the heat or the air conditioner. There's free installation, and that's not a typo on there. They will pay you $25 to do that. Ladies, another thing, we're hitting this common theme where the solutions for climate change actually save you money. Incandescent light bulbs are the old style of what we're used to, where the light bulbs are inefficient. They've been around for well over a century, and a standard 60-watt bulb, there you buy it, it's the cheapest, it costs $1.25. The amount of electricity that you use over 50,000 hours is 3,000 kilowatt hours. The cost of the electricity is $300. So over 50,000 hours, that means it will cost you $352.50. In the 90s, they came up with compact fluorescent light bulbs, and that's pictured right over here. These light bulbs are quite a bit more expensive. See, they cost $3.95 per bulb, and the price actually has gone down quite a bit from what it originally was in the 90s. They last quite a bit longer. See, the incandescent bulbs, they have 1,200 hours of light. The compact fluorescent light bulbs, 10,000 hours of light. Instead of 60 watts of energy per bulb, for the same amount of light, it's 14 watts. And the total cost over 50,000 hours, it's $89.75, quite a bit less. The LED, it's a little bit less money than that, and that's $85.75 altogether, and those bulbs last even longer. And those actually are safer for the environment than the compact fluorescents, because the compact fluorescent bulbs have mercury in them, so you have to be careful in disposing of them. Compact fluorescents are a bit newer. You have an example in your phone. The flash that you have for the camera of your phone is LED. This is a solar power flashlight that I have that's also LED. And unlike the compact fluorescents, it's dimmable. This here is called a BOGO flashlight. The place where you can get this is www.sunnightsolar.com. And the reason why I'm putting a plug in for this is because whenever you buy this one, they will give one to someone in an undeveloped country. And it's very good for them because those people tend to be off the grid. They can't just flick on a switch to turn the lights in their home because they don't have electricity. This can help them because it's solar powered. What it does is it charges the batteries, which are in here, and very good for us to have because it's good during a power failure. So when we had a tornado here a couple of years ago, this is very helpful. During Hurricane Sandy, this wasn't all that helpful because Hurricane Sandy was in the fall and there wasn't enough sunlight in order to get a good charge out of it. Now we come to other strategies, and some of these we've in a sense already covered into what you can do. Generally, you can cut the use of fossil fuels. Shift to natural gas. Even though natural gas is a fossil fuel, it is cutting fossil fuels because natural gas is the cleanest of the fossil fuels. So it overall cuts down on the pollution too. Also, shift to renewable energy. We'll be getting into renewable energies later on in the year. But in general, renewable energies would be things like wind power, solar power, hydrogen cells. The main ones are wind power and solar power. Improve energy efficiency, which is what we saw examples of that, and our cars are profoundly more efficient now than they were 20 years ago and even just 10 years ago. Slowing population growth we've covered already. Another thing that helps too is rather than having the developing countries rebuild the wheel, we can just transfer renewable technologies and our efficiency technologies to the developing countries. Another important thing is the pipelines that carry the fossil fuels themselves and the facilities that process them, repair any leaks. Another one's very popular with the oil companies and power plants is carbon capture and storage. And basically what's done there is you take the carbon dioxide out of the air and store it. Several ways of doing this. First one we're going to cover is biological sequestration, where basically living things take the carbon dioxide out of the air and it gets stored in the living things and it gets put back into the carbon cycle itself. One way is reforestation. You need to use specific trees. You can't use trees that live for only a short time because when those trees die and decay, then that will release that carbon back into the atmosphere. You need to pick trees that live for 100 years, 150 years, or even longer. Like if you walk through Alley Pond Park, particularly in the forested areas, like there's a stretch that goes along the Cross Island Parkway, you will find some trees there that are older than our country. The carbon gets stored in these trees and they stay there until the tree dies. And yes, those trees will eventually die, but at least they get released into the atmosphere much more slowly. Restoring wetlands is a good way because these wetlands cover only 6% of the area of the Earth, but they contain, I think it's 14% of the carbon. So and it's all stored in the wetland soil, which is a carbon sink, meaning it's able to hold a lot of carbon. And actually, the wetlands were the original source of many fossil fuels hundreds of millions of years ago. And there's agricultural sequestration, where the goal is to store that in the soil. And ways to work with that is first is conservation tillage. For example, there's no-till agriculture. And really what you do there is that you just try to prevent or greatly reduce erosion so that the carbon is going to be kept in the soil and the soil will stay there. Another way to continue that is to use cover crops in between planting seasons so that the roots for these cover crops will keep the soil in place. Another form of biological sequestration is to use the ocean, and for that a ship will come along and then we'll add iron to fertilize the ocean. That will cause a phytoplankton bloom. Phytoplankton are the plant planktons. This is controversial because this may upset the ocean ecosystems. Simple burial, like in a landfill, will sort of mimics the process that created fossil fuels in the first place. Also, there's subterranean injection, and this has been done since the mid-70s, where carbon dioxide is injected into a depleted oil or gas reservoir or into the deep ocean. And yes, in the deep ocean it will eventually come back up to the surface, but that will take at least centuries. Transportation is a major cost for subterranean injection because the sites of most of these reservoirs are far from the sites of most carbon dioxide emissions. For example, one of the main sources of oil in the world is in Saudi Arabia, and the population of Saudi Arabia is fairly low, so the amount of energy they use is fairly low, and most of their oil is shipped abroad. So transporting carbon dioxide to Saudi Arabia would be a major cost. Like, for example, they send their oil to Japan, they send their oil to China, they send their oil to Europe. The carbon dioxide would have to be sent back to Saudi Arabia. For chemical conversion, carbon dioxide is made to react with calcium oxide or magnesium oxide. That will turn it into a carbonate, like calcium carbonate, which is calcite, which is a main part of limestone, and also magnesium carbonate. And these are solids, and they are then out of the carbon cycle. There are quite a few objections to CCS, or carbon capture sequestration. One is that doing these things will divert tax breaks and government subsidies from developing renewable energy. Another is that CCS power plants, they're more expensive to build, they're more expensive to run, they also use more energy to run. Any gain may actually be somewhat or even mostly offset by the energy to sequester it. And also today there are no incentives for this. Like, our government has not made carbon expensive to emit. Other countries have done that as a part of the Kyoto Protocol, which we haven't signed, and we will get into that later on in this podcast. Also, CCS is an unproven technology, and it can only remove part of the carbon dioxide emitted. Also, as part of this, no leaks can be permitted. The carbon that's sequestered has to be sequestered forever. This is even more extreme than nuclear technology, because something that's radioactive does not remain radioactive forever. We only have to, when we put radioactive waste away, we only have to make sure that it's put away for thousands of years. And that's a lot shorter than forever. The Kyoto Protocol is a treaty. And in 1997, when Bill Clinton was president, 161 nations negotiated a treaty in Kyoto, Japan to slow climate change. The United States took a lead in negotiating it. It went into effect in 2005, with 174 countries ratifying it by 2008. The United States never ratified it. The reason why the United States never ratified it was because George Bush, who was president then, he made the conclusion that following the Kyoto Protocol would be damaging to the United States economy, so he decided that the United States comes first before climate change. So the U.S. did not participate in the solutions that were proposed in the protocol. The main goal of it was to require participating developed countries to cut their greenhouse emissions to at least 5.2% below 1990 levels by 2012. And one way to do this was to put a price on carbon. It allows greenhouse gas emissions to be traded, so that if a country or a business has reduced its emissions, then it receives credit for that. And then it can bank them to use later. Or if it has another area of its business where it is releasing too many greenhouse gases, it can use them in that area, or can sell those credits to another company or a business which is emitting beyond its cap of emissions. This type of trade is called cap and trade. Here's another strategy called climate stabilization wedges. The top diagonal line here is the projected emissions of fossil fuel. And the different colors you see here are a combination of different strategies, and different countries can choose which strategies they would use. And they are non-fossil fuel strategies. And those would substitute for emissions. Like the straight line that you see going up there, that would be what the fossil fuel emissions would be if we only used fossil fuels. And the reason why it keeps going up is because as more and more undeveloped countries go through the demographic transition, the amount of energy being used will go up, so the amount of fossil fuel emissions will go up. Also, as the world population goes up, more people using energy, so emissions will go up. So in order to bring that down, like we can't bring down the amount of energy, but we can bring the emissions down by using things other than fossil fuels. And if you look on the right, these are different things that could be used, and you could put different things in, different amounts of things, to bring the amount of emissions down to the level that would be desired. You could put wind power in. You can increase vehicle efficiency, nuclear power plants, concentrated solar thermic energy. I saw that in the movie where you saw a solar tower with reflectors, where they boil water that turns to turbines. Solar photovoltaics are the solar panels, like what you see on the roofs of houses. Biofuels are another. Ending deforestation, planting trees would be another. Now we come to our concluding questions. Number 1, name a challenge facing us in terms of solutions to climate change. Number 2, list the main strategies. Number 3, what are 2 things that you plan to do now that you've watched this podcast? Number 4, what treaty addresses climate change? That concludes the podcast, and I will see you in class tomorrow. Away from the goal, then you don't have to move the puck all that much in order to make it miss the goal. But if more time has gone by and the puck is closer to the goal, then you have to make a much greater change to the puck in order for it to miss the goal. So the sooner that we make the changes, the less we have to do in order to avoid disaster. There are 4 main strategies that are involved in combating climate change. One of these is to improve energy efficiency to reduce fossil fuel use. The second is to shift from using non-renewable fossil fuels to renewable carbon-free energy sources. Examples of carbon-free energy sources would be things like using wind power, using solar power, using hydroelectric power, even using nuclear power. A third would be to stop cutting down tropical rainforests. 2 reasons why tropical rainforests are involved with this. One is that they're able to soak up the CO2 that are in the atmosphere. Also, burn will lose out. Like if sea level rises enough, there are nations that will disappear. There are island nations that should be completely underwater. But we won't really know who the winners will be and exactly who the losers will be until it is too late. Also, many solutions will disrupt economies and lifestyles, but waiting too long will be more disruptive. I'll give you a sports analogy for making changes. Let's say in hockey you want to block a puck from going into a goal. If you're far past a tipping point, the effects could be around for thousands of years. And this challenge we covered in an earlier podcast. The long-term political issues are very hard to solve because most of those who feel the effects of climate change have yet to be born. We see today how hard it is to solve short-term issues. Long-term issues are even harder. And when there's climate change, there will both be winners and there will be losers. There are nations where they'll actually benefit from climate change. And there are, of course, nations where they will. Hello, in this last of our climate change podcast, we're going to be looking at solutions for slowing climate change. And our learning targets for this podcast is that we will understand how individuals can slow climate change, and we'll also understand how laws, policies, and treaties can slow climate change. First, there are challenges. One is that the problem is global. It requires international cooperation. Now, the effects are long-term, so that the CO2 emitted today will be around for 120 years. And if we